Okay, so here we are with some more right triangle trigonometry today. We're going to start off by looking at SOHCAHTOA. All right, so we'll talk about what SOHCAHTOA means, but first of all, let's take a look and see what we got going here. All right, so when we talk about sine, cosine, and tangent, sine is opposite over hypotenuse. That's where the O and the H come from in SOHCAHTOA. Cosine, oops, in this case, all right, so I'm going to look at the triangle at the same time here. So if I look at sine of angle A, the opposite side is A, and the hypotenuse is C. When we look at cosine, cosine is adjacent over hypotenuse. That's where the A and the H come from in SOHCAHTOA. So if I'm looking at angle A, the adjacent side is going to be side B, and the hypotenuse is side C. So the adjacent side and the opposite side will never be the hypotenuse. Okay? If we look at tangent of A, tangent is defined as opposite over adjacent. So in this case, that's going to be A over B. Okay? If we look at sine, cosine, and tangent of the other angles. Okay, so here's B up here in the right corner. So sine of B would be opposite over hypotenuse. That's going to be side B over side C. Cosine of B, that's going to be adjacent over hypotenuse. That's going to be A over C. And tangent of B is going to be opposite over adjacent, which is going to be B over A. Okay, so there's your trig functions for a triangle. Let's take a look and see what's up next. It says find the sine, cosine, and tangent of angle B. All right. Now I can do, if I look at angle B here, I know that from angle B I've got the opposite side and the hypotenuse. All right. So I can definitely do one of the three trig functions with that, but I can't do the other two. So if you ask yourself, okay, which trig function fits with opposite over hypotenuse, that's tangent right there. So I could do the tangent of angle B, but I can't do sine or cosine. Oh, excuse me. I'm sorry, no, opposite over hypotenuse. The sine. Already making mistakes here. Okay, so I could do the sine, but I can't do the cosine or the tangent. So I need to find this other side down here at the bottom in order to do those two. So I'm going to start off by doing that. So I'm going to find my missing side. How am I going to do that? Pythagorean theorem. So I'm going to call that side down there A. And so I'm going to do A squared plus 12 squared equals 13 squared. If you solve for A after you square these guys, okay, you're going to end up with A equal to 5 here. So now that I know A is 5, now I can start filling in my ratios. Sine of B is opposite over hypotenuse, so I can definitely do that one. That's 12 over 13. Cosine of angle B, so from angle B here, adjacent over hypotenuse, that's going to be 5 over 13. And finally, tangent is opposite over adjacent, that's going to be 12 over 5. Pretty straightforward, right? All right, this one's all yours. Pause the video for a second and give me the sine, cosine, and tangent, or it looks like cosine of A and sine tangent of B. All right, so cosine of A. First of all, I'm gonna start off here by finding the missing side again, since I'm doing multiple angles here. So to solve for side B, I'm gonna plug in, do my Pythagorean theorem again, and I'll end up with B equals 24. Cosine of A is going to be defined as adjacent over hypotenuse. So A up here at the top, adjacent over hypotenuse is 10/26, and I can reduce that to 5/13. Sine of B. All right, so from B, I'm going to go opposite over hypotenuse. That's 10 over 26. Hey, look at that. It's the same thing as cosine of A. Imagine that. Tangent of B. Opposite over adjacent, 10 over 24, that's going to simplify to 5/12. All right, given right triangle ABC with angle A equal 40 degrees and C equals 12 centimeters, find side B. Notice up here your calculator needs to be in degree mode, so if you're using a scientific calculator, you should probably be in degree mode, but you just want to check that. If you're using a graphing calculator, let me pull out mine here. Pause. Okay, so here's my graphing calculator. If you're in here, you're going to want to go to find the mode button right up here at the top, the red one. So you can click on the mode button, and then you'll scroll down 2 or 3 lines where it says radians and degrees. We want to make sure that we're in degree mode right now. Okay, so we're going to hit enter. All right, and then you can just hit the second key and quit, and you'll be back to the normal screen, and now you're in degree mode. Okay, so let's take a look and see what we got here. First thing we're going to do is we're going to look at labeling our triangle maybe. So I'm going to put everything in the right spot here, and I'm going to look at what am I supposed to find? I'm supposed to find side B. That's down here at the bottom. Alright, so you notice side B is across from angle B. This is side C across from angle C, and so on and so forth. Okay? So what I want to do is I want to look at, what am I given? I know angle A, and I know the hypotenuse. I need to find the adjacent side. I need a trig function that fits with adjacent and hypotenuse. So again, take a look. I've got angle A, I know that's 40. Now, granted, I could find angle B as well, because I know that all triangles have to add to 180. So I know that the corner angle is 90. 90 plus 40 is 130. So this angle up here, if we subtract that from 180, B would have to be 50. So I could actually do the angle up here very easily as well. But I'm going to stick with the 40 down here. And again, what I'm looking at is the hypotenuse and the adjacent side. Okay, so adjacent and hypotenuse, that fits with cosine. So I'm going to start off by plugging in for cosine. So my angle is 40, my adjacent side is B, my hypotenuse is 12. And now I just need to solve this for B. So I'm going to put this whole thing up in parentheses, and I'm going to multiply both sides by 12. To get the B by itself here, I have to multiply by 12. So I'm going to do that on both sides here. So that's 12 cosine 40. The 12s cancel out here on the right side, and B equals 9.2. Piece of cake, huh? All right. You try this one. Alright, so first thing I would do is label everything here. It says to find side C, so I did label that. This time I've got, if I look at my 32 degrees here from angle A, I've got the opposite side, and I want to find the hypotenuse. So opposite over hypotenuse, that's a sine function. Alright, so I'm going to go with the sine of angle A here. Here we go. So I know that sine 32 equals 24 over C. This is a little different from the last one. Okay, I want to get the C all by itself, but I can't leave it in the denominator. So I'm going to take that other side, I'm going to put it over 1, and then I'm going to cross multiply. Okay, I think this is the easiest way. I'm going to cross multiply the C and the sine 32, and I'm going to cross multiply the 1 and the 24. So I have C sine 32 equals 1 times 24. I know that this is just 24 over here. Okay. But then, to get rid of the sine 32, I want to divide it out to get the C by itself. So I would divide both sides by sine 32, and then I would take out my calculator and pop this in my calculator, 24. Use the fraction keys, all right? We want to make sure that we're using those. So I'm going to bring up my calculator again, and we'll come back over here, and we're going to punch in C equals, we can't do C equals, so I'm going to get a fraction here, alpha, y equals number 1, and I'm going to type in 24 on the top, and I'm going to type in sine 32. You'll notice it opened parentheses down there, so I'm going to close those parentheses, hit enter, and I get 45.289. Okay, 45.289. I come back over here, and I've rounded to 45.3. Okay, so there you go. I think that's it for this one. Sure is. We'll see you on the next one.